Alright, time for another draftphysics.com, debatephysics.com also. And on the Debate Physics website, there is, well, I'll provide the link below to the email conversation between me and Paul Nord. And over a month of negotiating what has turned out to be an experiment that is already well done, okay, in a version of it anyway. This idea of trying to tease out the truth, whether there's kinetic energy or momentum is driving the universe. And so what you need is these really simple experiments done to demonstrate the truth. And I've pointed out ballistic pendulums and spacecrafts in different ways where kinetic energy completely fails to show that it can do any work whatsoever. And, and then there's these little bit of collision experiments where they play games with the truth and don't recognize that springs don't give back their energy as well as they collect it. Just a fact. And take advantage of that to deceive. So anyway, Bruce Yeany has done the actual experiment, both the tug of war, sort of. Well, not really the tug of war, but he's definitely done the crash test, okay? Smashing the two things into each other and see what happens. And the evidence is decisive. And so, again, another nail in the coffin. In the sense, you can't use these basic crash tests. So unless they have some gimmick, where they try to compare two different experiments done in different ways and then say, look, it doesn't match, because the experiments have broken the comparison. But in the simple case where it's just Newton's laws, kinetic energy will fail. So, like in a lever, for example, and pulleys, for example, fails dismally if they'll do the experiments. So anyway, so this is just, I was right in the middle of complete depression because, it's just impossible to get Paul Nord to stay on the subject and actually do an experiment that isn't a rigged piece of crap. And he wants you to somehow admit that his rigged piece of crap experiment is somehow viable and useful when it's a rigged piece of crap. Anyway, just might as well get to it. So I'll play this. It was just ironic that I found it today, and it's 7 months old. 2 years. It's 2 years old, and I'm saying, well, how the hell did I miss this? So I'm going to enjoy it, okay? Just because it's just so... It's such a clear illustration. So nowhere in the video does he say the words kinetic energy, and he just talks about Newton's laws. And so it's just a demonstration of how that's how they play the game. All of a sudden, kinetic energy doesn't mean anything when they're talking about experiments where there's zero evidence of its existence. All right, so I think I just have to hit a button or two or something, so I'll pause and do that. Hit the wrong button. Anyway, so continuing. I'm playing more of this than I need to, but it's, I'm just kind of enjoying it, so I'll have a selfish indulgence.
In opposite directions.
So by pulling on the scale, doesn't matter which one you pull on, it's always the equal pressure on both objects. So whether you're pushing or whether you're pulling, they both collect the same force for the same period of time, blah, 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 blah. So they collect the same amount of momentum.
Even as the amount of force changes,
as Newton would say, twice the force, twice the velocity, 3 times the force, 3 times the velocity.
Each block is always feeling the same amount of force as the opposite block.
So this is just the standard collision, okay, so he's released one, but when he releases both of them, then you'll both be going half the speed. So you really can't see that in the video, right? So, but the fact is if you hold one of them down and you move the other one, it goes twice as fast. And then if you let both of them go, they each go half as fast. It takes the same time for their impact to happen, but it happens because both of them are moving half as fast. So there we go. Oh, he did. He's holding it again. Now, there. He let both of them go.
Try this again.
So the velocity is at half. It's over here and it's over here instead of being in one object. All right. So here's the same experiment again.
I stretch them out 1 meter. Where should they meet? in the middle of the meter stick.
In the middle. Okay. Well, let's see if that's right.
A little more volume, I think. I'm not sure, but I could use a little more.
3, 2, 1.
So they meet in the middle, and one of them doesn't win the crash, obviously.
I've doubled the mass on this one. Stretch it out.
There you go. Okay, so we have twice the mass. Now the only catch is it's a little slower because of the friction. So he's going to talk about that later. Obviously, the double mass object isn't going to be able to collect the same amount of its portion isn't going to be equal because it's actually experiencing twice the friction.
Which ones feel it? Which one's getting more force? Which one's getting more force?
Equal.
See, so yeah, even the little kids know it, and you people don't.
3, 2, 1.
Yeah, so there's no evidence that the collision moved. So, you know, he's
Out
plays it
here.
in slow motion. All right, that wasn't very slow. But obviously the one board slides off the other board, so it's not perfect. But even under that circumstance, where the heavier mass broke, it still didn't push it. So the thing with twice the energy, so let's understand the one block by their kinetic energy theory has twice the energy. You know, not an insignificant amount. I got some issue I have to take care of. All right, back. No rest for the weary, as they say. Anyway, so he does it 3 and then 4, so it gets even more convincing. The more the differential, the less evidence of any difference. Here goes, bang. So, absolutely zero evidence that this lighter piece of wood that's got twice the energy. So just understand, it has twice the energy. That's the 5-ton train going 10. And it just collided with a 10-ton train going 5. And it clearly didn't win. It didn't even come close to winning. It didn't do anything even indicating it won. Okay, proving kinetic energy is garbage because they keep saying it's the definition of it is the capacity to do work. It clearly can't do any work. It can never do any work. It can't move a spaceship. It can't be collected in a ballistic pendulum, and it can't even move a piece of wood. All right, so now we got 3. So it's 3 times the energy now is going to be in the lighter block. It's going to be going 3 times the velocity, 3 squared, 9, you know, the whole thing. So there's 3 times the energy in the lighter and the smaller block. And there's going to be no evidence of 3 times the energy.
The force is always the same on both blocks, but as we increase the mass on the one side, it decreases the distance.
There, again, no evidence that it plowed the whole thing over. 3 times the energy, okay? Just understand, it has 3 times the energy. Not just 3 times the velocity, 3 times the energy. And it completely failed to demonstrate it has any more energy. I mean, how can you people keep ignoring something that basic? I mean, you can't get more basic a physical interaction. They're smashing into each other. They're testing each other. It's like 2 weights testing each other on pulleys. And clearly, there's no evidence that this kinetic energy thing can work, that it actually can do more work.
That it moves.
Friction.
Now, another area that I use.
Oh, I thought he did 4. Maybe he'll show up. Maybe it's in here somewhere.
Use these blocks for is a basic demonstration of friction.
Students have a lab activity.
Well, maybe that was 4, and he didn't do slow motion of that one. Yeah, we'll see. All right. Yeah, that's 4. 1, 2, 1, 2. Yeah, I think that was 4. I think.
Now, another area that I use these blocks for is a basic demonstration of friction.
Students have a lab activity where they measure how friction affects various surfaces. After completing the lab, I can then go over the results on a larger scale using the blocks.
Yeah, friction. So obviously friction isn't a force. It's just you giving energy to the ground. You're shaking it, vibrating it, jiggling it, as Feynman would say. And so you're just basically transferring the motion that one object has and giving the motion to something else.
One suggestion is to use furniture polish on the table before using it to let the block slide easier.
Any oil will do.
Now another possibility is to add some wheels to the blocks.
Simple plastic wheels nailed into the sides of the blocks can improve the
So, plastic wheels, which makes so much more sense than the little metal wheels they use on the professional carts, right? So why are the professional carts using metal wheels? That store a whole bunch of angular momentum. I wonder why. Yeah, because it helps make the experiment comes out their way. That's why. It's a rig.
performance.
Like asking why does a magician shove pigeons up his sleeve? Yeah, why? That's the show.
As it decreases the amount of friction.
All right, so these experiments aren't very illustrative of anything except, obviously, if things aren't connected to each other, one can't move the other because it's not making enough contact. Contact is really important. So when springs are compressing, they're always in contact through the whole process of being compressed. So when I compress a spring with a force, the spring is constantly in contact. And it's only when it's releasing an object that all of a sudden it loses contact when it's still moving. So you can understand springs collect energy really well. They release energy really poorly. So, not terribly fast. It would have been better if we'd been doing some more crash tests. So here again, the lighter object is going to hit the board with 3 times the energy. But there's not going to be any evidence that it hit with 3 times the energy. And it's too bad he just doesn't nail all those boards together so you could actually see the contest. So no evidence the lighter one has 3 times the energy, just saying, right? There's just 0 evidence that that light object is hitting that board with 3 times the energy. Clearly looks the other way around. Looks like the thing with 4 boards now is going to look like a lot more of an accident than the one.
Comparing the blocks with wheels versus
There, so here we go. This is what we like. All right, so we have 2 to 1.
without wheels.
2 to 1. So this has the lighter block has twice the kinetic energy. And now it's going to hit something with 1/2 the kinetic energy. And it's not going to win.
We find the position of impact.
Not even close to winning. Nothing. No forward progress at all. Nothing. No evidence it had twice the energy.
differs by about 5 seconds.
So here we go again. So yeah, so he's just saying wheels help. So here we go. 3 times the energy now. So this is 3 times the energy against 1 unit of energy. The 3 times the energy really should win, shouldn't it? I mean, if it's going to be able to do work, doesn't have to show that it can do work. Isn't doing work pushing something? It has 3 times the pushing power, the doing work power. How come there's going to be 0 evidence that it has 3 times the power?
Centimeters.
Boom,
So it's
nothing.
not a big change in our results.
0.
But when I use the blocks without the wheels, friction is part of
Okay, so I think this is 4, maybe it's 3
the
again.
discussion.
It looks like 4. So now this one's a little trickier because you can tell that, okay, that one's probably doesn't have 1/4 the velocity because there is a lot of friction now. But still, no evidence of 4 times the energy. 4 times, okay, there's 4 blocks here. The little car has 4 times the energy. 4 times, okay, that's a lot more, right? I mean, if this is this much, 4 times is 4 times. It's a lot more energy. This is like a 400-pound person against a 100-pound person. It's a huge advantage here, and it's not going to show any advantage. Nothing. Zero. Zero progress for the thing with 4 times the energy. Come on. I mean, the point is you people already knew this was going to be the answer. You already know that this is the truth. You didn't need me to show you this. And you just pretend it's not true, that it's not an obvious demonstration that kinetic energy can't do work, that it doesn't exist. There's no evidence of its existence. In the simplest experiment you can possibly do, crashing 2 things into each other, there is no evidence of the kinetic energy existing. Boom! Nothing. A perfect demonstration of the fact that they have an equal amount of energy, they have an equal amount of capacity to do work, everything about them is equal because they have the same exact momentum. It's the same force just coming back to roost. The same exact amount of force, the same exact amount of weight. Both of them, as they're moving, would compress the spring the same amount because they have the same amount of force. Oh, I love this. Boom! Nothing. Okay, I just locked the little one out a little bit. But no evidence that it's 4 times the energy. Nothing close. All right, I haven't watched this part, so we'll watch this.
Box, or you simply want to go larger, you can do all the same demonstrations using cardboard boxes.
Wow, very exciting.
And it's also very easy to change the mass. Just simply put something inside the box.
Well, that wasn't much of a something, frankly. Well, it was enough. Yeah, do the collisions. Collisions.
Now, one more use for these boxes is to turn them into a game.
Oh, no. Not interested. Ah, yes.
I came up with a couple different games of inertia shuffleboard, and I'll be sharing these in a later video.
Good. I can pass on that one. All right, so again, he's talking about inertia, talking about friction, talking about all the other subjects except the one most clearly illustrated, which is any conversation about kinetic energy would show it to be a farce, because nowhere did it demonstrate itself to be having anything to do with reality. It completely failed to have anything to do with reality. All right. So I guess I'll just read the last couple of emails between me and Paul Nord. And I just, the last one is the one where I actually pointed out this, these simple experiments. If you want to do these, simple experiment to prove that kinetic energy fails, well, this is the one to do. And so it is kind of ironic. So I'll be back. All right, here's some of the email anyway. So he said in one part, humor me by imagining that I can do this experiment with an ideal spring and 0 friction. So we've been arguing about an experiment and how I've been saying it's overtly flawed, that you cannot possibly do a fair experiment this way. And he keeps saying the same thing. And I'm like, I don't see any good science point in doing that, right? I mean, how can you sit there and say, well, give me your explanation for what happens in an idealization, and instead I'll do a very unideal experiment. And we'll say that your idealization prediction is somehow your prediction for the experiment, when I pointed out over and over again my prediction for the experiment is that it will catastrophically fail because springs don't give back all the energy they collect, and they do that unevenly. That is, they penalize faster objects a lot more than they penalize heavier objects. I've said it over and over and over again, and he just keeps ignoring the argument. How come this isn't updated? All right, so we have to refresh this. Yes. All right. Let's see. Okay, so he said here, it's clear we aren't getting anywhere. The real physics model makes quantitative predictions and can be tested. So again, it has nothing to do with predictions and testing. I wasn't opposed to any of those things. I'm just saying that you can't test whether an experiment doesn't work. There's no point in telling me, let's dent clay with round objects to see how much energy it has. And I'll say no, because it has no viability to get to that truth. It's going to deceive you. It is not going to reveal the truth. And why should I have to concede that somehow your experiment is going to show the truth when I know it's just going to deceive people? So I said, he says, it's clear we aren't getting anywhere. And I said, agreed. The subject was whether levers and pulleys conserve momentum. So this whole thing started because of Steve Mould's video and my clear assertion that it's absolute crap for somebody to argue the law of the lever doesn't work and that levers don't conserve momentum. It's just flatly wrong. It's bad science. It's bad physics. He defended it, okay, as being real physics, and that was the real subject. And somehow it got turned into pucks. But anyway, it also would have been nice if you could prove it takes 25 times the force to spin something 5 times as fast. I pointed out that the experiment you're proposing is one I've seen a dozen times already, and none of them produce credible or conclusive results. So I showed the podium launching, the rubber band off a pendulum podium. And I showed the fact that when you launch the heavy object, there's maybe 4 times more momentum in the podium. That somehow the equal and opposite reaction is gigantic, and so is the cannonball's flight. So clearly the argument is that it just happens to be a fact that shooting light arrows will impart less momentum to the arrow, and shooting heavy arrows will get more energy into the arrow for the same pull on the bow. Just a fact. Okay, a real physics model makes quantitative predictions that can be tested. I said a real physics attempts to account for variables. You wish to exploit ignorance of them to fool people. Just like the 1700s where they dented clay with round objects and claimed it proved. Okay, so he says, every time I try to pin one down, you avoid answering. And so I just point out, oh, that's just a lie. I don't mind being pinned down, but I'm not going to be pigeonholed into saying something I don't believe. I'm not going to sit there and say, I predict your experiments will produce the idealization, because they won't produce the idealization. I stated clearly what my objections were. And he says, claim ideal physics is pointless. Well, of course I claim ideal physics is pointless, but I said, you're trying to pass off garbage as pristine. Okay, our shift to a different problem. Another lie. I pointed out right from the beginning that experiments with springs are troublesome and a lever fixes the trouble. So I made that point right from the beginning. I argued for the lever launcher kind of experiment. He somehow thought it was impossible to do a lever experiment, and to me, obviously, we've seen them. They're not that hard to do. If your model can't even define the variables clearly, and he says another, so I say another lie. I've made it clear that momentum is always conserved, momentum in, momentum out. So there's no math I need to do here. I'm telling you, if you put 4 pounds on a spring and you measure 4 pounds on the spring and you have it compressed there and now you release it, then if you use a device that can collect the energy from the spring, then you'll get 4 pounds. But obviously the whole point is springs can't do that, because all the motion in the spring is, there's always a waste, because it loses contact with the object it's pushing. It's pushing 4 miles an hour. The object goes 4 miles, 0.1. And now the object's moving faster than the spring, so the spring can't push it anymore. But the spring's still going 4 miles an hour, so obviously all that energy is wasted. All the energy the spring still has, it can't get it into the object, so it just wobbles back and forth, which means it will stop the recoil. The podium doesn't move in the launcher because the light object leaves so much energy in the spring that the spring's oscillations dampen all of the motion. They take away the recoil. All right. Let alone predict outcomes. I predicted your results will convincingly prove nothing. Okay, then it isn't a compelling theory. I believe in conservation of momentum. You believe in conservation of kinetic energy. You won't do the crash test. You won't do tug of wars. You won't do any experiment that will decidedly prove your theory is garbage. And so he says it's just an opinion. He's saying because somehow my argument is just an opinion, when no, there's the argument is over the evidence that exists, and I've made it clear that ballistic pendulums prove momentum, rocket ships prove momentum, and I'm arguing levers and pulleys prove momentum, and I'm arguing these crash tests will prove momentum. So bullshit. I haven't evaded anything. Let's see. If you had the guts to do the lever experiment, the opinion would be proven to be absolute fact. I'm happy to discuss real physics. Yeah, you'll only discuss it in text, which is just so pointless. So I point out, without force diagrams, you can't reasonably discuss physics. I'm not going to keep chasing a conversation that leads nowhere, because you want to pretend bad evidence is good evidence, was my argument to that. I mean, that's all he's doing. I mean, I pointed out how it's not fair to do a launching experiment with a light object and then compare those results to launching a heavy object, because the thing you launched with gave them uneven amounts of energy, and it's just a fact. That's what it did. Okay, I've tried to show you two different experiments that illustrate exactly the same thing, and apparently you're not interested enough to watch those videos. So, I mean, I showed the videos. They're only 2 minutes long. He still won't watch them. Just tell me what you want to measure about the configuration. And I'm like, whatever. You need to guarantee both objects are given the same force. Otherwise, the experiment is a waste of time. Okay, then make a velocity prediction. I've repeatedly pointed out the lighter setup object will get less energy from the rubber band, and the more mass, the more energy from the rubber band. The experiment with the lighter objects might produce 500 total momentum. The heavier object might produce 2,000. So clearly the rubber band can't have more energy. And so obviously one of the experiments isn't allowing the energy in the rubber band to be converted into motion. It's just obvious. The rubber band can't make 2,000 joules or 500 joules. All it can do is you can collect all of it, the 2,000, or you can collect way short. All right, so he says, I'll also make a prediction and can compare data to theory. I've explained how the experiment is rigged and unfair, and you're showing too little integrity to concede the argument. I mean, I'm just saying, he's saying I have to say the experiment isn't a piece of garbage, and of course I won't do that. So then he says, you've dismissed the experiment before seeing the results. Of course, because I understand what the experiment's got a flaw in it. I don't need to see the flaw because I've already seen it a dozen times in other experiments. And I showed it in the video how there you launch heavy things, you get a lot more momentum than if you launch light things. Physicist Michael did the experiment with the stupid carts. In one experiment, the same spring creates 1,500 momentums. Same exact spring compression. In the next experiment, he collects 3,000. What's the point? I mean, obviously you're not accurately collecting the energy. You're not evenly collecting it. All right, you've dismissed the experiment before seeing the results. No, I've clearly explained how the experiment cannot produce useful scientific results. You can't make a fair comparison if the two objects aren't given the same energy. So so I wrote this before I found the Bruce Yeany video. So it is just kind of like 5 hours earlier. Tie 5 or 6 rubber bands together and then tie them to your two different pucks, 1 mass and 2 mass. Separate the pucks by a meter or so and let them go. I mean, it's exactly the Bruce Yeany experiment. The 1 mass puck will travel twice the speed and by your theory have twice the kinetic energy. Yet when they collide, the collision will not be moved in the direction of the lighter object, showing no evidence of twice the energy. So it's right there. And then I point out how you can do the opposite. Or launch the 2 pucks in opposite direction using your device. Tie a piece of thread to both carts, allowing them to have a tug of war. So you just put a spring between them and launch them. And then have a piece of thread that runs out. And the two will just be stopped. And nobody's going to win the tug of war. All right. Once again, the half-mass puck will have twice the kinetic energy, but it won't win the tug of war. Showing the kinetic energy can do no work and therefore isn't real. So anyway, and then he says, that tells me no test will ever convince you. And I said, this is like saying no magician will ever trick me. Okay, it's a compliment, thank you, into believing in magic. And then I say, most of physics is just contrived deception. And that's what it is. They can't accurately describe the double slit. They can't accurately describe Eddington's experiment. They can't accurately describe anything. And they just use these niche experiments to deceive people. And that's all it is garbage. There are no quarks, there are no neutrinos, there is no antimatter, there's never going to be a qubit. The whole thing is crap. And it all goes way back to this stupid crap theory that somehow velocity should be squared for no good reason. All right. Oh, it seemed a fairly decent rant, but you can see, just so ironic, huh? You know, curiously coincidental that I find the video after I described exactly what I was looking for, and I found exactly that video. So that was really a pleasure. So sorry for being cheerful. I won't do it again, right? There's just no chance there'll be a good reason to be cheerful again. Because this planet sucks, and the humans on it suck, and everything sucks. So anyway, I'm quite satisfied. Maybe I'll just call that the video. I don't know if I need to say any more. This is a pretty big boom piece of evidence. And again, all people can do is throw rationalizations, right? So let's just hear all the excuses for why kinetic energy can't move a rocket, it can't be collected in a ballistic pendulum, and it can't be demonstrated in crash tests. No point in doing crash tests because we're showing that it completely fails to do any work. Yeah, okay, that's your theory. That's your well-evidenced, reasoned, logical theory that you're going to defend. Is one that fails every real test. Every test that can't be finagled, it fails. Fact. All right. Enough of video. Again, they're never going to have an experiment where they show you it taking 25 times the fuel to move something 5 times as fast. This will never happen, ever, in the history of this universe, because this universe doesn't do that. God damn it. How can you people actually believe that crap could be true? Just how? How do you believe that? I have to kick a ball 25 times harder to make it go 5 times as fast? Shit. That's just shit. All right, anyway, till the next time and such. God, I just hate this planet. But right at the moment, I feel like shit, but mentally, I'm relieved. Yes, we found an experiment. So, thank you, Bruce Yeany. He didn't do it on purpose, of course, but he did it nonetheless.